This is section 1.5, conditional statements for geometry. Your learning objective is I can write conditionals and find their truth values. Pay attention to a new vocab word of counterexample. It's an example that shows a statement or conjecture is false. We're going to look at the explore and reason section, and we are going to see that this is a cause and effect chart. And cause and effect number 1 says, if it is raining, then it is spring. We're going to only look at this first one together and read our construct an argument question. It says, determine whether each effect is always true for the cause or not necessarily true for the cause. So we're going to determine that then it is spring. Is that true if it is raining? Take a second and kind of think about that. Is that a true statement, always, that if it is raining, it must be spring? Can it rain any other time of the year? Yeah, totally. It totally can. So if we're thinking about if this is always true or not necessarily true, this one would be not always. Not necessarily. Not always true. And we could give a counter example to even further prove that. And the counter example could be that it can rain in any season. So just because it is spring doesn't necessarily mean that it's raining. Or the other way around. Just because it's raining doesn't mean that it is spring. Those things don't work like that. And that's kind of what this section is going to be about, is conditional statements and finding out whether they're true or not. So, first example says to write a conditional. Well, a conditional is an if-then type of statement that relates a hypothesis, which is the part after the if, to a conclusion, which is the part after the then. And we write that as P then Q. And we say that as if P then Q, where P is the hypothesis and Q is that conclusion. So let's read our first example A. It says a triangle with all angles congruent is equilateral. And we're going to write that as a conditional, but first we have to determine what is the hypothesis and what is the conclusion. The hypothesis follows our if and gives the condition. Well, the condition here is that we are a triangle with all angles congruent. So that would be our hypothesis. Meanwhile, the conclusion gives the outcome or the result, which in this case is we are equilateral. So if we wanted to write this as an if hypothesis, then conclusion statement, we would write this as if a triangle has all angles congruent, then it is an equilateral triangle. This statement here would be our conditional statement. And we know that this isn't necessarily how we would speak in everyday talk. In everyday talk, the hypothesis doesn't necessarily come before the conclusion, but we're practicing writing it that way. So read example B. Alberto can go to the movies if he washes the car. Determine what is the hypothesis, what is the conclusion, and write that conditional statement. Pause to do that. All right, now that you're back, did you determine that the hypothesis was if he washes the car, and the condition or the outcome would be that he could go to the movies? Let's see, did you write it as if Alberto washes the car, then he can go to the movies? Great. Well, example 2 has us determining if things are true or not, and we call that a truth value. The truth value of the statement is truly either a T for true or F for false, and it is either one of those things according to whether the statement is actually true or false. So let's read this conditional of part A. If a quadrilateral has a right angle, then it is a rectangle. Think about what you know about quadrilaterals. It just means that it's 4 sides. So then you have to determine if something has four sides, does that make it a rectangle? Can there be something with four sides with one right angle, a right angle, that isn't a rectangle? And we're going to use a counterexample. If you can find a counterexample, then we're false. What about a shape like this? It has a right angle. We're just going to draw a little shape, but it's got four sides. Is that a rectangle? No, it's not a rectangle. But is it a quadrilateral with a right angle? Yes. So this would be our counterexample, and that would help us prove that this conditional is false, just by thinking of that counterexample. So read try it B. If x is the midpoint of AB, then x lies on the segment AB. Read that and determine whether it is true or false. What did you decide? Did you decide true? Then great job. Because by definition of a midpoint, it must be a point on the segment. Because this was saying you have some segment AB, let's call it AB, and if x is the midpoint, then it does have to lie on the line. So that would be true, a true statement. Let's go on to example 3, talking about converse. The converse reverses the hypothesis and the conclusion of a conditional. It literally just flips it around. So instead of if hypothesis then conclusion, it does it the other way around. And it says if conclusion, then hypothesis. So let's do an example of that. This statement here says if, and our hypothesis is a polygon is a quadrilateral, then it has four sides. We're going to write the converse of that just by flipping it around. We're going to say if, and then we're going to write a polygon has four sides. I'm going to abbreviate polygon. So we just put the conclusion first. Then, now we're going to put the hypothesis. It is a quad. I'm just going to abbreviate that, a quadrilateral. Now let's read that converse statement. If a polygon has four sides, then it is a quadrilateral. Is that true? Yes, and we just kind of reviewed that accidentally above, that a quadrilateral is just a shape with four sides. So this one works either way. Try it with part B. Flip it around. If two angles are complementary, then their angle measures add to be 90 degrees. Write the converse and then determine whether it is true or false, the truth value. Let's check our converse. Remember, the converse just means we're going to flip it around. So the converse would be, if the measure of the two angles add to be 90, then they are complementary. So we have reversed it. We've flipped around the hypothesis and the conclusion. And this statement actually is true as well. If the measure of two angles add to be 90, then they are complementary angles. And that's by our definition of complementary angles are two angles that add to be 90 degrees. But the converse isn't always necessarily true. Sometimes when you flip it around, it isn't true anymore. So you do have to be a little bit careful when you're finding that truth value of the converse. This was section 1.5, conditional statements.